Okay, for this video lesson, we're going to learn the difference between rational and irrational numbers. Okay, so first we're just going to go through these two columns of numbers. And then we're going to look at this other column, or this other box, excuse me, sorry about that. So first, we're going to look at the numbers in both columns on the left, and then we are going to analyze these numbers on the right and find if there is a pattern. Okay. So let's start on with column A. Okay. So the square root of 16 is equal to 4. Okay. And I would encourage you to feel free to go through this column and simplify these as much as you can, okay? Note that this negative is outside of the brackets, okay? So just kind of forget about it and leave it outside. And remember, anytime you're taking the square root of a fraction, take the square root of the numerator and the denominator separately. Oops. Square root of 4 is 2. Okay, so we got negative 3 over 2. That's a 3. Okay, 2.5. Can't really simplify that, but note that it is a terminating decimal. Okay, same with 7.3. Cube root of 8 is 2. And 4 to the negative 0.5 exponent equals 0.5. Okay. Note that these are all whole numbers or fractions or numbers that have terminating decimals. Okay. Now let's go over to column B. So square root of 27 is 5.196 and a whole bunch of other numbers. Cube root of negative 16 is negative 2.519 and a whole lot of other numbers. Pi, just press pi equals, you have 3.14 and a whole bunch of other numbers. Negative 6 to the exponent negative 0.5 is equal to negative 0.408. Okay, negative square root of 3 is equal to negative 1.732. Bunch of other decimals, and square root of 2 is equal to 1.41, and a bunch of other decimals. Okay, so hopefully you're starting to notice a pattern here, okay? And I kind of suggested it earlier, right? Column A, this has whole numbers. Or fractions. Whole numbers, fractions, or decimals that terminate. Excuse me. Okay, terminate. They end. Okay, so whole numbers, fractions, or decimals that end, these are going to be rational numbers. Okay, I know we kind of talked about it a little bit yesterday, but or in the last lesson, so just reiterating that here. Okay, and in column B here, we have unlogical decimals. Okay, unlogical decimals that do not end. Okay, your calculator just rounds them off at that last digit. Okay, so these are going to be irrational. Okay, so let's go ahead and let's look at these 4 numbers in this box right here. Okay, so I would like you to pause the video and go ahead and simplify those and see where they go and see if you got it right when you pause or unpause, okay? So cube root of 25 into the calculator. That comes 2.924 and a bunch of other decimals. Okay, so therefore that one should go into column B. Okay. Next. So 1 divided by -4 to the exponent -0.5. Put that into your calculator very carefully with brackets, and you should get a -2. Okay, so a -2, it's a number that ends. So this should go in column A. Okay, the square root of 4 divided by the square root of 25, that can be simplified to 2/5. Okay, which is a fraction, so that can go right into column A. Okay, lastly, the negative, we're taking the 4th root of 16, and there's a negative in front of there. Okay, punch that into your calculator, and you will get -2. And therefore that is going to go into column A as well. Okay, so the purpose of this exercise is just to communicate that we're having different types of numbers, okay, that you're starting to learn the different terms of, okay, rational and irrational. Okay, so just to summarize what we've just talked about, and to give a nice definition. So the numbers in column A are called rational numbers. Okay, and the definition of these numbers are any number that can be written in fractional form. Okay, so these types of numbers, so these include whole numbers, all fractions, or decimals that terminate. Means end, or repeating decimals. Okay, so rational numbers, any number that can be written in fractional form. These numbers include whole numbers, all fractions, or decimals that terminate or repeat. Okay, so the next column is our irrational numbers. Okay, so these are decimal numbers that do not terminate. Might be a little bit easier to identify. Decimal numbers that are non-terminating and do not have a pattern. That repeats. Okay, so for example, 2/3 as a fraction. If we convert that to a decimal, it'll be 0.6 repeating. Okay, so because that has a repeating decimal, we would consider that to be a rational number. Okay. All right. So consider the cube root of 50. Okay. So if we punch this into our calculator, we get 3.684031499. Okay. Now, even this 9 here is rounded up from something. Okay. So this decimal number here is irrational. But if we were to write it, the cube root of 50 is the exact value. Okay. So in math, we like to use exact values. And it's also a lot easier for our notation to write the cube root of 50 as opposed to 3.684031499, right? A lot less for us to write down. Okay, so writing the cube root of 50 like that in radicand, or like as a radical, is the exact value of the number. But the number itself, 3.68403, is an irrational number. Okay, so we always like exact values, not rounded irrational numbers. Okay, so writing cube root of 50 as a decimal that ends is an approximation of this irrational number. The number 3.684031499 is written as a rational number because it terminates. Okay, so just to summarize, so the cube root of 50 is irrational, but exact. Okay, once we put that into our calculator and we get 3.684031499, because that last digit is rounded, it is a terminating decimal now. So we would say that this is rational, but not exact. Okay. And these two numbers are not exactly equal. If we were to cube this decimal here, 3.684031499 to the exponent 3, that actually equals 50.000000001. Okay, so not quite exactly equal. Okay. So just to summarize what we've just been talking about, any number that terminates is a rational number. Any number that is non-terminating is irrational. Okay. Together, the rational and irrational numbers form the set of real numbers. Okay. And real numbers include the natural numbers. So think of these as your counting numbers. Okay, 1, 2, 3, and 4. Our whole numbers are going to be our counting numbers and 0. Zero, 1, 2, 3. Integers are positive and negative counting numbers. Okay, so -2, -1, 0, 1, +1, +2, etc. Okay, and then we have rational numbers. So these are going to be all fractions and all decimals that terminate or repeat in a pattern. Okay, lastly, irrational numbers are those that do not repeat. And have no pattern. Okay, so if you're like, Jones, but aren't all numbers on my calculator then technically rational numbers because it's rounded? Well, how about this? If it has like all of the decimal places and it gets rounded off, that's irrational. But if it only has like 2 or 3 or 4 decimal places, then that's a terminating decimal. So then that would be rational. Okay. So I'm just pulling up an image here that is just going to kind of summarize the relationship between all types of numbers. Okay, so we have rational and irrational numbers. And within those rational numbers, we have integers, whole numbers, and natural numbers. Okay. So if it's a natural number, it's a whole number, it's an integer, it's rational. Okay. If it's just an integer, like if it's a negative integer, it would not be part of the whole numbers or natural numbers. Okay. And if it's like a negative decimal number, that would be considered as just rational. Okay, so we'll start with number 3. And I'm just gonna move down a little bit so I can. Right. There we go. Okay. So we're going to go through these numbers on the list, and if you feel like you're able to do this on your own, feel free, and then go ahead and check your answers once you've done this on your own. Okay. So number 3, so this is a natural number. It's a whole number. It's an integer. And it's rational. Okay. -5 is not a whole number, but it is an integer. And therefore it's rational. Okay, so this is a really long decimal. So irrational. 0 is not a natural number because it's hard to represent 0 in nature. But it is a whole number. It's an integer. And it's rational. Okay, the cube root of -64. Might not be able to tell what this is right away, but if you put that into your calculator, you will get -4. Okay, which is an integer and rational. Okay, pi is irrational. Okay, this decimal does not end, and there's no pattern to it. Okay, 1/2 is represented as a fraction, so it is rational. Negative 0.6 is rational. The terminating decimal. The square root of 36 is 6, so that is natural number. It's a whole number, integer, and rational. Square root of 12 negative. Punch that into your calculator. It is a non-terminating decimal, so it is irrational. The cube root of 8/27. Cube root of, so anytime, again, we're taking the cube root of a fraction, take the cube root of the numerator and the denominator separately. So the cube root of 8 is 2. Cube root of 27 is 3. Okay, that is a fraction. And if you turned it into a decimal, it would repeat. So it is rational. And taking the square root of a negative number, we cannot do that. So square root of negative 18 does not exist. All right, hopefully you have a better idea of what makes a rational or irrational number now, okay? Okay, so using a number line, we're going to order these values from least to greatest. Okay, so because they all have different indexes, and some we're taking the cube root, some we're taking the square root, and some we're taking just we're taking a fourth root. Let's get these, instead of comparing apples and oranges and bananas, let's just compare apples. So let's see what all of these values are. So we enter the cube root of 13 to our calculator. We have 2.35 and a bunch of decimals. Cube root of 18 is 4.24. Cube root of 9, square root of 18 is 4.24. Square root of 9 is 3. Fourth root of 27 is 2.279. And the cube root of negative 5 is negative 1.709. Okay, so we have some negative values and some positive values. So on the bottom, let's go, our range is negative 1.7 to 5. So let's go negative 3. Okay. And now we can go in and start plopping these values. So the cube root of 13, 2.35 is about here. Cube root of 18, 4.24 around here. Sorry, the square root of 18. Square root of 9 is 3, so that's going to be right here. The fourth root of 27 is 2.2. So a little bit on the inside. That is the fourth root of 27. And lastly, the cube root of negative 5 is negative 1.7. So that's going to be right around here. Okay. Cube root of negative 5. Hopefully you can see that yellow okay. Okay, if I ask you to show your work, you should create a perfect square, perfect cube, perfect fourth number line like we did in the last video lesson. If I don't say that, don't worry too much about that. All right, you're welcome. Okay, so that's all I have for you guys today. So there is an assignment for you guys to work on now that you've watched these 2 video lessons. So feel free to take a little bit of a break and let's get cracking on those practice problems. If you need help with anything, feel free to send me an email. I'd be more than happy to help you. Thank you for your attention. Have a good day.